So now we're going to look at an example involving triple integrals. So let's evaluate the integral from 0 to 1, 0 to x, 0 to the square root of xy, x dz dy dx. So here I'm getting 0 to 1, 0 to x. You work from the inside out. So first integrate with respect to z. You'll get xz. So then you're going to plug those in, your bounds in place of z. You'll get x times the square root of xy. So I'm going to rewrite this as x to the 3/2. So then integrate, again working inside out with respect to y. So you'll get the integral from 0 to 1, x to the 3/2, y squared over 2 from 0 to x. So I'm getting 0 to 1, x squared over 2 minus 0, so just leave it off. And now we're going to add the exponents together. So this will be the integral from 0 to 1, x to the 7/2. So do your reverse power rule, add 1 to the power, so it'll be x to the 9/2. Divide by 9/2, which is the same thing as multiplying by 2/9. These 2's will cancel, and then you're left with 1/9 being your final answer. All right, so there were some more problems we did with applications of triple integrals. You should look back at those where we were finding volume and things like that. The last thing I want to mention is what we did with change of variables. In particular, we found the Jacobian. So how did we do that? So find our Jacobian. What you're doing is you're changing your variables. So here I'm changing from x and y to u and v. So then to find our Jacobian, it has a very nice formula. And the partial of x with respect to u, the partial of x with respect to v, partial of y with respect to u, the partial of y with respect to v. And so it's the determinant of this 2x2 matrix. And remember that the reason we care about the Jacobian is it tells us what extra stuff goes in our integral when we do a change of variables. Like remember in polar coordinates we add in an extra r. So let's look at an example. Let's find the Jacobian for the change of variables. X is going to be u minus v squared, and y is going to be u plus v. Well, to find our Jacobian, I need to find our partial derivatives. So let's look first. We need to find the partial of x with respect to u and the partial of x with respect to v. So with respect to u, the derivative would be 1. The partial derivative with respect to v would be negative 2v. If you look at your equation for y now, the derivative with respect to u is 1. The derivative with respect to v is also 1. So then you just need to take the determinant of this 2 by 2. Remember, it's diagonal minus the other way. So this is going to be 1 minus a negative 2v, or 1 plus 2v. And that is our Jacobian. There. So I know there was a whole lot more that we did with multiple integration, double integrals, and triple integrals. You should definitely review a lot of that material